Over the next couple of lessons, we will be training our naive Bayes classifier. But what does this involve? The training step primarily involves calculating the token probabilities. We need to work out the probabilities for an individual word or token. Now, if you haven't watched the lessons on probability theory and the Bayes theorem from the previous module, pause here and watch them now before you continue. You'll recall that the formula for conditional probability under Bayes' theorem looks like this. This formula gives us the probability of an email being spam given that it contains the word Viagra. To work out the final numbers for this formula, we need a couple of things. First off, we need the overall probability of an email being spam. Second, we need the probability of Viagra occurring in any email. And third, we need the probability of an email containing the word Viagra given that the email is spam. This calculation boils down to 5 numbers. So what are these numbers that we need to work this out? The first number at the top is how often the token in question, in this case the word Viagra, appears in spam emails. The second number is the total number of words in spam emails. The third number is the probability of spam emails occurring in the first place. On this slide, I've put this number at 55%, but we'll actually work this out from our training data. In the denominator of this fraction, we have our fourth number, the total number of times that the word Viagra occurs in all emails, both in spam emails and in non-spam emails. And finally, we got the total number of words that we looked at across all emails in the first place, both spam messages and non-spam messages, across the entire dataset. The Python code that we're going to write next will tease out a couple of these numbers. With these numbers in hand, we can calculate the relevant probabilities for our tokens. This is effectively the training step for our naive Bayes classifier. I'll add a quick markdown cell here that reads, training the naive Bayes model. And our first subheading here will read, calculating the probability of spam. In the slide, I had this set at 55%, but I think we should work this out from our data. This actually makes for a very good challenge. I'd like you to quickly calculate the overall probability of spam. We'll assume that this is the percentage of spam messages in the training dataset. Store this value in a variable called prob_spam. I'll give you a few seconds to pause the video and tackle this challenge. Did you have a go? The total number of messages that we have in our dataset is full_train_data dot category dot size. We've got about 4,014 messages. The number of spam messages is full_train_data dot category dot sum. The reason I can do this is because I've labeled the category of spam as 1 and the category of non-spam as 0. So simply summing up all the ones in my category column will give me the number of spam messages, of which I've got 1,249. Therefore, the probability of spam, prob_spam, is in fact equal to the training data category dot sum divided by full_train_data dot category dot size. And that we can print out as probability of spam is, prob_spam. There we go. It's around 31%. This is the first of the numbers that we're looking for in our Bayes theorem. The next number that we're looking for is the total number of words or tokens. We need to count the total number of tokens that we have in our dataset. And we also need to calculate the number of tokens that belong to the spam category and the number of tokens that belong to the non-spam category. But first, let's create the total number. What I'm going to do is I'm going to create a subset from our full underscore train underscore data frame. I'll call this subset full underscore train underscore features. So this will be just the tokens. I'll set this equal to full underscore train underscore data dot LOC. LOC is for selecting a number of rows. Square brackets, colon. This is for selecting all the rows. But I'm not going to select all the columns. I'll just select the columns with our word IDs. In other words, I'll leave out the category column. LOC is perfect for this. To leave out the category column, I'll just say, well, take all the columns that you've got, full underscore train underscore data dot columns, but don't pick the category. So I'll say not equal to single quotes category. That exclamation mark that you see here is Python syntax for the logical not. Together with that equal sign, this logical condition here reads not equal to category. So I'll pick all 2,500 columns except the category column. Now, mind you, this string here is, of course, case sensitive. Let's look at the head of full underscore train underscore features and see what this data frame looks like. There you go. We've just excluded a particular column from the subset using logic. Now, how do we get the total number of words? Well, let's take a two-step approach. Let's sum up all the tokens per email. So if you think about it, we should sum up all the numbers in this row. Then we should also sum up all the numbers in this row and all the numbers in this row. That would be the total number of tokens per email. We can do this really, really easily with the sum function. So I'm going to store this thing in a variable called email underscore lengths. So that will hold on to the total number of tokens per email. And to use that sum functionality, I'll grab my features data frame, full underscore train underscore features, and I'll use the sum function. But I'll provide an argument here. I have to specify how this function should sum things, right? Left to right, bottom to top, up to down. We have to be a bit more specific, and we can do this with this axis parameter here. Axis is equal to 1. This will sum up our columns. Let's take a look at what email underscore lengths dot shape gives us. So we've done the summation, and we've got 4,014 emails. Exactly what we want. The first 5 of these look like this. Email underscore lengths, square brackets, colon, 5. And we see that the first email has 50 tokens, the second email 76 tokens, the third email 87 tokens, and so on. So what we've got here is a handy little pandas series of all the tokens. To get the total number of tokens, our total word count, if you will, all we need to do is sum up the values in the entire series, right? I'll store this number in a variable for later use. So I'll say total underscore WC for word count, and I'll set that equal to email underscore lengths dot sum. To see what that value is, I'll just put total underscore WC below and hit Shift Enter. And what we see is that we've got approximately 446,000 tokens. Looking back at our formula here, we've now worked out this white number here and this blue number here. Now let's work out this green one. Let's work out the total number of tokens within spam and also within the non-spam messages, which is not shown on this slide here. I'll add this as a markdown cell. Number of tokens in spam and ham emails. I reckon this actually makes a good mini challenge. Can you create a subset of the email length series that only contains the spam messages? Call this subset spam underscore lengths, and then count the total number of tokens that occur in this subset. Also, do the same for the non-spam emails. Create a subset called ham lengths from the email underscore length series, and then also count the number of words that occur in the non-spam or ham emails. I'll give you a few seconds to pause the video and give this a go. You ready? Here's the solution. What I'm going to do is I'll create this variable spam lengths, and I'll subset this whole thing from email underscore lengths using the square bracket notation where my full underscore train underscore data dot category is equal to 1, double equal to 1, that is. That's the logical condition to create the subset from email underscore lengths. The number of emails that are spam are, of course, spam underscore lengths dot shape. Here we can see we've got 1,249. To get the number of words or the number of tokens that are in the spam emails, I'll store this whole thing under spam underscore WC for word count, and I'll set that equal to spam underscore lengths dot sum. And if I print this out as an output, we can see that we've got approximately 195,000 different tokens that are part of the spam emails. This is the first part of the exercise. The second part of the exercise, doing the same thing for the ham emails, the non-spam emails, we can write ham underscore lengths, set that equal to email.lengths, and subset this whole thing based on the condition that full underscore train underscore data dot category is equal to 0. In this case, ham underscore lengths dot shape will show us that we've got 2,765 ham emails. A good thing to do at this point maybe is check your work, right? Email.lengths dot shape square brackets 0 minus spam dot underscore lengths dot shape square bracket 0 minus ham underscore lengths dot shape square bracket 0 should be equal to 0, because the two subsets together should have the same number of emails as our dataset as a whole, right? This is a quick check that you can do to make sure you've subsetted things correctly. The total non-spam word count, the word count for the ham messages, should be equal to ham underscore lengths dot sum. And this value is equal to 250,000 approximately. And again, I think this is a good time to also do a quick check. Spam underscore word count plus non-spam underscore word count minus the total word count should be equal to 0. There we go. I've actually got an add-on challenge for this. I just thought of an interesting question to ask. Do you think that the spam emails or the non-spam emails tend to be longer? Which category do you think has longer emails on average? What I'd like you to do real quick is to take a quick guess and then verify it in the data. How would you go about doing that? Here's the solution. I'm going to print out the average number of words in spam emails. This is going to be spam underscore WC divided by spam lengths dot shape square brackets 0. The average number of words in the spam emails in our dataset is approximately 156, 157. If this number is a little tough to read, we can actually format this much more nicely with curly braces, colon, dot, 0, f. That stands for float. I'll get rid of this comma and I'll write dot format, and I'll put the calculation inside the method call here to format. Here I'm rounding to the nearest whole number. This is a nice little trick if you want your print statements to look pretty and not give you a lot of numbers after the decimal point. Let's compare this to the ham emails, the non-spam emails. We'll take the ham word count or non-spam word count and we'll divide it by ham_lengths.shape. And just to show you how this string formatting works, I'm going to have a 3 here instead of a 0. So we'll get 3 decimal points in our output. There you go. So we can clearly see that spam emails actually tend to be wordier, which I think is actually quite interesting as well. Now that we've got our big headline numbers in our formula sorted, we need to take a closer look at the tokens themselves. We need to sum up the tokens that occur in the spam messages and the tokens that occur in the normal emails. And we need to do this for each token, for each single word ID. And we'll get right on that in the next lesson. I'll see you there.